But if we extrapolate this out and this actually does start to manifest into a reality where these agentic agents are able to execute tasks,
Mhm.
you logically need less humans in the loop. And if it gets to the point where they're not just executing tasks and specific workflows, but entire job functions,
Mhm.
what happens then? Welcome to the Talking AI podcast, where we talk AI with both experts in the field and early adopters. I'm your host, Matt Paige, and we're here to demystify AI for you so you can get some value from it. Let's talk some AI. Generative AI and the power of LLMs has amazed us all over the past couple years. But when you get down to brass tacks, there's some major gaps and issues that need to really be resolved for this technology to fully integrate into the enterprise, into our works, into our lives. LLMs still hallucinate. They don't have access to all of our proprietary data. And at the core, they're lacking memory in a lot of senses. But ultimately, there's a gap in the operating system of today and what will require for future LLMs to take full advantage, a new emerging operating system, if you will. And that's why today's guest and topic of the emergent AI stack is going to be super relevant and timely. And today we're joined by Amir Behbehani, founder and chief AI engineer at Memra. And Amir is an AI research scientist with previous exits to both Google and Meta. And Memra is making agentic AI real with their platform that helps build, deploy, and automate your workflows through AI. But welcome to the podcast, Amir.
Pleasure. Thank you.
And did I hit Memra correct? What's how would you define Memra and what you all do?
I think the root of the word, there's a cognate that has to do with memory, and it also has to do with the word, actually. So we're risking a little bit of a pun there. And the idea is that we're working on both kind of a memory management layer for both long-term
Mhm.
and short-term memory to help contextualize um, interactions with LLMs. So
And
I think
memory is
I think
such
you
a
got it.
big component that is lacking in some ways with how we're working with LLMs today, a huge opportunity area. What other gaps or problems do you see with how we interact with LLMs today versus like where you see it could go in the future? What are the main things holding this technology back from really being mainstream in the enterprise in our everyday lives?
So the main thing that I think about is instead of having human beings interacting with GPTs to surface information, maybe making the human being marginally more effective at whatever it is they do, from writing code to writing a document, et cetera. The way I think about these things is if the automated systems are leveraging the GPTs to then engage in performative actions. For example, reading from a data store and then writing via an API to then perform a set of actions that result in a set of tasks being performed on behalf of the human or VM. I sometimes think about this when you're engaging a GPT, is the conversation being by and large in the interrogative. But when you're engaging with, for example, agentic AI, the conversation is mostly in the imperative. So if you
Yeah.
think about, there's the imperative, the declarative, the exclamatory, the interrogative, you're asking questions.
Mm.
With the imperative, you're giving a command. Now, when we talk about memory and we talk about reasoning and we talk about agentic AI, there is sort of an interrogative dialogue that's happening behind the scenes. You can think of it as a Socraticism. However, that's happening by the agents, not by the human being engaging in that Socratic dialogue to fine tune the thought process. The fine tuning of the thought process is happening automatically. The human is just saying, for example, write my documents to a database. Of course, there's a lot of questions that invokes. What database? What's the username and password? What's the path to that database? What data do you want me to write to the database? What document But of course, if you have agents behind the scenes that can answer that, first of all, that can ask those questions, then can answer those questions and maintain in memory as context the correct answers to those questions, then you have something, in my opinion, pretty powerful. And that I refer to as agentic reasoning.
Yeah, and that's an interesting topic there. You're talking about this concept of agentic and the agentic nature of AI and where it could go. And today, it very much is. You almost have to have a human in the loop. Like I almost
Mhm.
equate it to today. We're very manual in the way we interact with AI. A one-to-one relationship. I see this future-looking view where it is very much autonomous in nature, one to many. It could be many agents interacting with many agents. Maybe there are humans in different areas of the
Mhm.
orchestration. But the big gap you mentioned, say you're interacting with an AI today, whether it's Chat GPT or whatever, it doesn't have access to your data. And if it does, it's on a very manual type of scale. I'm like connecting to some document within the frame of the context. So you mentioned orchestration, and I almost like to shift over to the emergent AI stack, right? So, and
Mhm.
I'm actually going to pull this up for folks that are watching live. But yeah, the emergent AI stack, it's got 5 different layers as you define it. But let's start with the bottom layer, LLMs and other models. That's the foundation in essence. Start by taking us through, and if you want to set some context for the the emergent AI stack, feel free as well.
And so, I wrote this paper about a year and a half ago, and I think the thoughts were still culminating in my mind. I was trying to reason through, is there going to be some sort of AI stack that is differentiated from existing stacks? And this was an attempt piecing together disparate concepts and disparate items. But I think a lot of it's relevant a year later. I certainly think that maybe, and there's a metaphor here as well. So in this sort
Mhm.
of emergent AI stack, as we call it, there is layer one, which we liken to, again, metaphorically, to the CPU of a computer. Sort
Yeah.
of layer two, we liken it to the hard disk or the store of long-term information, long-term memory. Layer three, we think of that as more of the short-term memory or the context window and things that accompany the context window. And then four, layer four, I should say, that is the agentic layer. That's which I should also say that each of the layers, as you move up the stack, there's like accumulation where layer four benefits from layer three,
Mhm.
benefits from layer two, et cetera. And then ultimately at layer five, there's going to be an application layer. I've seen some hints at some of the applications. There aren't that many of them. I think the majority of companies with whom I've come into contact so far with regard to the sort of this AI stack, they're all engaging at the infrastructure layer. But that's not to say
Yeah.
that the application layer is not around the corner. It probably is. And it'll benefit from the the other layers about which we've spoken. So that was the beginnings.
And start maybe take us through this data layer, which
Mhm.
is an interesting component because LLMs are trained on a ton of data,
Mhm.
huge corpuses of data, the entire
Mhm.
internet, but they don't necessarily have access to your proprietary data within your enterprise and whatnot. But as you can see there, it's connecting to your own relational databases. You have CRM, historical quotes. This was hitting off an insurance related use case, but it's almost translating it into these vector databases and knowledge graphs. Talk us through that component of it and
Well,
potentially even differences between the vector database knowledge graph. Is that an either or do they benefit having both?
yeah. So I think layer two, you may think of that as a RAG stack, right? So
Hmm.
the vector databases are involved there. Graph databases are involved there as well. And what we have found in our work is that you store documents or other forms of information in these vector databases. So you can turn the documents into embeddings, you store the embeddings in the vector database, and you can make a call to the vector database and retrieve some sort of set of similarities that you then augment your LLM with. So now you're taking effectively the private data on which the LLMs were not trained. So they have now sort of through this RAG stack, they have access to the private data. But we found that if you can categorize the density of information, then there are different stores of memory that you can then use to augment the LLM. So for
Mm.
example, in what we found is with vector databases, they're very good at providing answers to general inquiry or inquiries, general inquiries. Whereas graph databases, when they're much better when the density of information is higher. For example, if I'm looking at a document, I may say, what is this document? It may be a contract, it may be an invoice, et cetera. And a vector database is very good at providing context to answer that question. But if I want to know, for example, who are the parties to the agreement? What's the value of the contract, for example? Isn't document signed, et cetera?
Hmm.
Generally, the density of that information is much higher. And if that information is stored in a graph database and then retrieved and used to effectively augment the queries, we get much better results. Now, the problem with the graph databases is that after a while, they get they get so large that effectively they'll overflow the context window. So in our particular case, we vectorize the knowledge graphs as well. It's- We get the best of both worlds. We get the benefits of that sort of vector similarity search, but we also from the retrieval of very dense information, and we get very accurate responses, very precise answers, I should say. Um, so that's been our experience at that layer two. At layer three and four, we can talk about. But I will say, with regard to layer four, given that's the agentic layer, it's benefiting from whatever's taking place at the RAG layer.
Mm.
So it's not the agentic layer is not necessarily interacting with the documents directly. They're interacting with a representation of the documents, the
Mm.
RAG layer. So you want to make sure that it's not garbage in, garbage out, so to speak. You want to make sure the information with which you have to function at that RAG layer, in that embedding layer, is the best it can be, number one. And then number two, you want to make sure that you can retrieve from that layer as precisely as possible. That's why categorizing the information is important. And then retrieving information based on the category of information. And that category is really about density. How dense is the information at the RAG layer is going to define how effectively you're retrieving information at the RAG layer to then s- allow the agents to then do their thing, do whatever it is
What?
that they have to do functionally.
Why is the density important there? Is it just from a computational standpoint in dealing with more dense versus less, or how does that factor in?
I think that density has to do, again, probably it has to do with the limitations of similarity search.
Mm.
So cosine similarity is how these vector search engines work. They may use cosine similarity or dot product. Manhattan distance, Euclidean distance, these sort of these measures of distance, I think um, they're all very approximate.
Yeah.
So they're going to get some approximate region of that vector space and then use that to augment your query. Whereas in the graph database, there's still, if you're vectorizing the graph database, those subgraphs are, you also have that issue about um, the similarity metric being potentially a limiting factor. But I think on the edges of the graph, of the knowledge graph, there's just context that seems to benefit the retrieval.
Mm.
And so that might be a reason.
So as we move up the stack, so we get into layer 3, the context layer, and really the
Mhm.
layer 4, this kind of orchestration, which you have as the
Mhm.
OS layer. This is the new novel piece of this. And there's several components that are new and novel to this, but this concept of agents and having agentic capabilities
Mhm.
is a whole new way of us thinking about it. Like today, it's really humans kind of executing these different tasks, playing these roles,
Mhm.
tasks, building up to workflows, building up to processes, building up to entire functions
Mhm.
effectively. But talk us through that component and what's critical here. Because I got to imagine the agents have to know what type of data they can access, when they should access it, all these different components that play into their role that they're designed to do.
When the human is interacting with the GPT, they're maintaining context in their own mind and they're
Yeah.
winnowing down what information they want to elicit from the
Mhm.
GPT as a function of a context that they're
Yeah.
maintaining.
We have our own short and long-term memory in our mind that we're leveraging as part of that.
Preci- Precisely. Now, when you have these agents engaging and there's no human in the loop, if memory is not maintained and context is not preserved as precisely and as accurately as possible, you have parasitic effects. So a parasitic effect is when these error terms are being fed back into the reasoning process. And then you're exponentiating, or you're at least at a minimum, you're multiplying these error terms. And you get these agents that go awry
Yeah.
very quickly. Okay. They have rogue agents. That's right. And so their ability to perform complex tasks where complexity is defined by either a serial process that has a lot of intermediate steps, or each sort of task that comprises the overall workflow has a high degree of interdependence. And in those particular cases, the agents just go off the rails.
Mm.
So preserving memory and preserving the ability to know where to retrieve as needed, that seems to keep these agents um, on the rails, so to speak, for as long as needed to complete the task.
Yeah. So are there feedback loops you have in place that are hitting these negative scenarios to keep the system in check in essence, or is it not working in that kind of way? Or I know
Um,
you also talked about kind of master versus subordinate agents. Is there an interplay there as well between the different roles of the agents and what they're effectively doing?
with a master agent and a subordinate agent, um, memory comes into play again. So what does a master agent do? You give a
Mhm.
particular task. I'm sorry, you give a particular function to the master agent, write my documents to a database, for example.
Yeah.
That master agent has to effectively take that function and break it down into constituent tasks. And then the subordinate agents go and do each of those tasks. So it's almost like
Mm.
a map reduce process where
Yeah.
where the master agent is it's mapping to the subordinate agents the relevant task, and then maybe it's summing the sum, so to speak, at the very end. And how do you do that? Of course, memory. You have to store you have to store the state of the task, of the workflow, of the task being done pursuant to the overall workflow. You have to store that and manage that, and that becomes a memory management problem. So again, memory management comes into play there as well.
Is the memory management, is it taking place across all of these different layers and components in essence, or is there one layer where memory's coming into play? Is there memory effectively associated with each individual agent where it has its own shorter long-term memory, or how does that conceptualize across this stack?
I don't know, I've been thinking of it, everything in between the application layer and the
Mhm.
foundational layer is like a bus.
Yeah.
How I've been thinking of it.
Yeah. Okay. Interesting. And so if we go to the very tip of it, the app layer,
Mhm.
that's going to change as well. So effectively today, how we integrate with or work with applications, to your point earlier, it's very much kind of declarative. We're having to hunt and click and pick and basically execute the whole workflow ourselves via this GUI.
Mhm.
Where do you see that going in the future with these agents? Is it a completely different user experience, user interface that we're interacting with? Or,
Much much smarter application. So the
yeah,
simple use case, for example, is let's say you and I want to schedule a meeting.
yeah,
Okay. There's a lot of hunting and pecking just to do that, right?
yeah,
It's onerous. It's not particularly enjoyable. And maybe an assistant can sit in the middle of that interaction and facilitate that transaction. But
yeah,
that's how it's done with humans these days. But using an application that benefits from agentic reasoning, now you don't have to necessarily send a Calendly link. You don't have to go click it, find a time. And it just eliminates that necessary. That all the reasoning is happening behind the scenes. And there are already companies that are doing that. I think
mm,
there was a company, Block It, I think it was called. They're backed by Sequoia. That's an example. That's a company at at the application layer that's benefiting from agentic reasoning. And it's a very seamless interaction. You send an email to somebody, um, and the agents behind the scenes are resolving that double coincidence.
and it's this is effectively focused on that use case of scheduling meetings and that, not having to have this
Right.
kind of step in the middle of either us talking.
Correct.
Calendly took it to the next step where at least one person can view a calendar and select it. Now this is basically pushing that responsibility to the agent, and that solution's doing that,
Correct.
right?
That's right. Mhm.
What on the topic of use cases, what other use cases are you seeing, whether they're ones you're doing at Memra or ones you think are interesting and ripe to be picked off first? Because I have a feeling there's gonna be this group of use cases that are like easy, low-hanging fruit, and it's gonna progress from there. It's a harder, more difficult things to get the human out of the loop effectively.
The use cases that come to mind, and maybe even in the general case with AI, it's a lot of the use cases are where you have two-sided marketplaces.
Mm,
So let me speak the general case, not focusing on agentic AI, but AI more broadly. So if you think about Uber or this sort of these shared economy applications, one of which being rideshare, you have two demand curves. One of those demand curves is the demand for the riders. And then the other demand curve is the demand for the drivers. And there's a recursive cross-product price elasticity of demand function there, right? Adobe Acrobat Reader, Adobe Acrobat Writer, that's an example of like platform economics. And in the case of rideshare, there's a human driver. And that
Yeah.
creates the bipartite demand curve. Now, if you replace the human driver with a self-driving car, suddenly that bipartite market just becomes a single demand curve all over again. So now of course, you couldn't do that 10 years ago when Uber was brand new. So of course they had to foster a marketplace. Now, so that's more of a general case with AI. If you now focus with regard to agentic AI, one of the use cases that comes to mind, or one of the set of use cases that comes to mind, matching algorithms. So you maybe on a dating app, as an example, use machine learning to foster a match, or with job apps, job marketplace applications, maybe there's an algorithm, keyword matching, as an example, that matches the employer to the prospective employee. And machine learning is okay. It's certainly a worthwhile approximation, but how about if agents are doing it?
Yeah.
Vastly more dynamic. And maybe even the agents can leverage machine learning. Not saying they can, but certainly those marketplace interactions come to mind as a set of use cases.
That's interesting. And I think hitting on the double-sided marketplace, I think I saw Tesla teasing the other day with their new fleet of autonomous cars coming soon. So we'll see what happens with that. But that, to your point, that kind of takes at a whole different scale the human out of the loop completely on that whole side of the supply and demand equation there. But if we extrapolate this out and this actually does start to manifest into a reality where these agentic agents are able to execute tasks, you logically need less humans in the loop. And if it gets to the point where they're not just executing tasks and specific workflows, but entire job functions, what happens then? Where do you see the future of work going if this does start to manifest over time and extrapolate out to where you have whole job functions effectively being done by AI agents? What's the role of humans at that point?
That's a harder question. A labor market transaction has two sides to it.
Yeah.
There's someone who's selling their skills, and there's someone who's buying the skills. And to the extent that you're selling your skills and you're on the sales side of that labor market transaction, potentially you're competing with AI. And so you may view AI as maybe a threat, maybe a dampener, just the wage, or maybe you might even view it as, to the extent that you're leveraging it, although there's probably a governing factor to what extent are you leveraging it.
Yeah.
It may be improving your quality of life as you perform your particular job. But from the buy side of that transaction, AI is really powerful.
Yeah. Yeah.
So now the question then becomes is, if AI becomes a catalyst to change the extent to which one group of people are on the sell side of the labor market transaction, maybe they start moving to the buy side. Maybe they become more entrepreneurial. Maybe they decide, I'm not going to go to work at some company, but I'm going to become a vendor. That which I was doing at company XYZ, I'm going to strike out on my own and do that job as a vendor. Of course, it was like Ronald Coase that talked about why teams of persons come together within a firm. This whole theory of a firm. And the idea was what he termed at the time, when the marketing costs were prohibitively high. Of course, we call those marketing costs these days transaction costs, right?
Mm.
But if AI is coming and reducing those costs, then I don't know, maybe potentially it creates an environment where the person who would otherwise need to be part of a cohesive entity to reduce some of those prohibitive transaction costs, they may not face that barrier and will perhaps do something on their own. It's a hard question because it requires there's a lot of variables that go into it. There's
Oh,
political
yeah.
variables and
Yeah.
there's a secular nature to this. So it's hard to prognosticate, but yeah.
So on the shift in topic,
Mhm.
summation, that's become a common term now in the new age we're living in. At what point do you feel like that probability of either something being wrong, something pretending it's right and just making stuff up along the way becomes small enough to where we can effectively trust the output? Because I find myself at times where if it's a if I'm having a discussion around brainstorming a strategic conversation or something where I don't need actual it needs to be correct, then it's perfect, right? But if there's an element where I need the right answer, I find myself going back and fact checking. Do you think there's going to be a point in time to where that probability of error effectively is so small to where we can effectively trust the output? And is that kind of going back to this emergent AI stack and the operating system to where that becomes reduced so much to where you just trust the output, especially when you're working in some of these like enterprise use cases where messing up can mean very bad effects on the back end.
In our particular case, we're taking data.
Mhm.
So I mean, I'll just maybe answer the question to the best of my abilities from my experience with working with these LLMs. In our particular case, we're taking data that exists in documents, which are relatively unstructured, and we're
Yeah.
writing them to a structured relational database.
Mhm.
And it- it's one thing that we write the answers totally wrong. So
Mhm.
that's one element of it. But there's another element where we actually get it right. But every time we run the process to write another record to the database, even though it's
Mhm.
the same process, therefore it should be the same record, that record is written differently. So if you do this over time and you multiply it across the entire matrix, you have a bunch of dates as an example, and they're
Yeah.
totally formatted differently. Even though it's the correct date, it's
Mhm.
just one is forward slash DD forward slash YYY,
Yeah.
but the second one has the correct date, but it's just formatted. It's different. So what we found is that if we have some sort of manifest or instruction file, so this is in
Mm.
addition to categorizing the information density.
Yeah.
If we have some sort of manifest, then we're able to, again, it's not just reducing the hallucinations because this is not hallucinatory. It's getting it right.
Yeah.
It just doesn't know exactly how you need it to be formatted. So we've been able to reduce the heterogeneity of the data that are being written to the databases down to zero. So
Really?
there are techniques that you can use. And again, ultimately, these techniques boil down to you preserving context and leveraging memory.
Yeah.
And in so doing, you're at least in our particular case, you're eliminating the hallucinations and eliminating the sort of the variability of the results as well. And that's really important actually in our work.
I found it interesting too. I was looking at one of the demonstrations. I think it was on something posted on LinkedIn from you using Memra. What was interesting is at the AI agent level, it had specific um, workflows that it was designed to execute on. And if it came
Mhm.
across one that it was not tailored to use, it had that response back. I'm not suited for this or whatever it was, which I think is also impactful too, because there's this element of today, if you're just working with ChatGPT, whatever LLM, it's going to try and do it. But it had instructions that this is what I'm supposed to do. If I can't do it, then I'm not going to do it. Maybe there's another agent that can, which was another interesting element I think started to build in within the system as well.
Yeah, that's at the master agent level. So can you
Yeah.
imagine the master agent hallucinating a workflow? That's it's off doing its own thing. That
Yeah.
would be quite bad. Yeah, we're able to control the master agent quite easily. But some of the things that I'm speaking about in terms of the manifest, in terms of the embedding space, et cetera, that all has to do with the subordinate agents.
Mm.
And the subordinate agents, there's I like to think of them as runners in a relay race,
Yeah.
and they're handing a baton to the next runner. And if they're
Uh-huh.
not preserving context and memory, they're going to forget who's the runner from whom I have to grab the baton. And oh, did I have to grab the baton? And it's just that's a mess.
What is this thing I'm holding?
Yeah, what is it? So those are some of the things that, yeah.
So in today's world, I'm assuming you are uh, effectively building, architecting, engineering all of these master agents, subordinate agents. Is there a point in time in the future where there's a master agent actually creating subordinate agents on itself in kind of an agentic, autonomous nature, or solving workflows in just a better way than a human could define it? Is that something that could be potentially there in the future?
I think it's already being worked on. I
Really?
think you could, the base case is a master agent with planning capabilities.
Yeah.
So
Okay.
sometimes you can think of, it was like Frederick Taylor and his scientific management, principles of scientific management, where he's talking
Mhm.
about taking a particular function and breaking it down into constituent tasks. Of course, I mean, I guess that's the basics of division of labor. These agents effectively, the master agent is doing something very similarly, right?
Mm.
It's breaking tasks down into bite-sized pieces that effectively the LLMs that are powering the subordinate agents have a high probability of getting right. So the governing dynamic here, as opposed to like the division of labor with human beings, instead of it being comparative advantage, the governing dynamic here is maybe information entropy or some sort of measure by which the LLMs are just getting it wrong with some probability.
Mm.
So if you can control that, then I think that is a master agent that can take on large, complex tasks, break them down into their constituent, and then allocate subordinate agents to take care of those particular tasks.
Yeah, I feel like over time there's going to be this whole new slew of companies that are coming out that are effectively doing with just a few people plus agents what massive companies are doing today. And those massive companies have a whole different P&L and just all the operating expenses and human labor and everything that goes into it. So I think it's going to be very difficult for those to adapt because it's not just like the innovator's dilemma of past generations. I feel like it's a whole new level of the innovator's dilemma in essence that may be upon us with a lot of the existing companies that are out there.
Yeah. Yeah. It's a good point. Also, it's not just the paper pushers, so to speak, within an organization that have some added competition vis-a-vis these agents.
Yeah.
It's really the explicit knowledge worker.
Yeah.
And the explicit knowledge workers, these are software engineers, these are
Mhm.
mathematicians, statisticians, data scientists, et cetera. Yeah. There's
So on the topic of software engineering, just because that's in the area that we play in large part, where do you see that going? Do you see engineers completely being replaced? It's the more experienced engineers being able to leverage AI in a more exponential nature versus somebody that may be more junior in nature. Where do you see that discipline going in the future as this starts to progress?
I think what I see right now is that the efficacy of a software engineer vis-a-vis the GPT models,
Mhm.
that's increasing. And then to the extent that you're leveraging agents, yeah, maybe you're leveraging agents to help you with your software engineering tasks. Although ultimately, I think that agents are being developed to help the applications reason, not necessarily to help the engineers reason.
Mm.
Personally, I think from many years, I was working in the machine learning world, and there you have deterministic output
Yeah.
that you're trying to use to train a stochastic process because there are events they've actually taken place and you're using that as the training set. And then
Mhm.
your model, your predictive model is outputting um, results that are stochastic. With the AI stuff, it's the opposite. You have stochastic output and
Mhm.
you're trying to make it as deterministic as possible.
Yeah.
So I see the role of the engineer as doing that now, building the
Mm.
infrastructure to do the latter, just as the ML engineers in years prior have built the infrastructure, data pipelines, et cetera, to do the former. At least I
That's
find
interesting.
myself
Yeah.
doing that.
Yeah. So less in the weeds of actually writing the code and you're setting up the systems, architecting. That aspect of it becomes more valuable, more important, and less human intensive to do it, I suppose, as well. So the future, the last thing I'd be curious of, as much as you can share, where do you see the future of Memra going? Are you all building this future operating system? Do you see it in line with that? Is it a platform that you're looking to evolve and build into that people are leveraging? Where's the future of Memra going?
I think the future of Memra has a lot to do with the customers that we have benefiting
Mhm.
from the agentic solutions. We have the same, probably the same trajectory as any other startup, wherein you have to identify product market fit and lay the
Yeah.
scaffolding to realize that feedback loop or the set of feedback loops wherein your customers are benefiting from the product and the services. But in in the way that I see it, I think I would love to help companies that otherwise have manual processes um, and see a lot of those processes as automated as much as possible, and in a way that the human being commands these agents to do that. So when I think of like the decade prior, again, the machine learning, where machine learning was coming into its own. It was a decade about leveraging predictive models and outputting predictions and then consuming those predictions to do things. Now I see it as one where it's more about automation
Yeah.
and then probably leveraging optimization after. So probably when Memra will evolve into sort of servicing companies along those trajectories.
That's really interesting. I think that's a foundational area that a lot of companies need to start. It's start with your existing processes. Where can you begin to automate those? And it may shift your entire workflow altogether. I think sometimes people see the shiny object and they want to build some new customer facing solution right out of the gate. I'd say start internal, see what you can do there, start to build your muscle up over time, and then see where you can evolve it as it may relate to completely new revenue streams, products, solutions, all those kind of things.
I think so. And I think with regard to this conversation, as we spent a good amount of time talking about memory and infrastructure to preserve context and leverage it, that's all bottoms up.
Yeah.
When you're talking about a particular use case, a lot of that is top down. But my thought process is that unless you've given a lot of thought to this bottoms up reasoning,
Mm.
you're going to get a lot of errors just doing top down reasoning only. So maybe you want to do the top down reasoning from the perspective of the use case and GTM, et cetera, but bottoms up reasoning to make sure that you're supplying demand as accurately, as correctly as possible.
Yep. Said. Thanks, Amir, for being on the podcast. Where can
Sure.
people find you and find Memra as well? What's the best way to get in touch with y'all?
I'm Amir at memra.co, and that's memra.co. And the website is memra.co, memraco, or
Perfect.
memra.co.
Yeah, and check out the Emergent AI stack. We'll have that in the show notes. Really good piece that kind of talks through this new Emergent AI stack. Worth the read. Thanks for being on, Amir.
Sure, man. Thank you, buddy. See ya.
Thanks for listening to the Talking AI podcast. If you enjoyed the show, give us a follow or subscribe on your favorite podcast platform. And don't forget to leave us a review. We love those. For more info on Talking AI, visit talkingaipodcast.com.